There are many terrace-type structures in Peru. Their total area amounts to approximately 1 million hectares. This represents a significant potential, but today, it is hardly utilized. Only 10% of these structures are in constant use, while another 20% are used sporadically. They have been fairly well studied and described. The problem, however, is that researchers do not classify them based on masonry type. At best, they note differences in the quality of stone processing. Literally, it is stated as follows: the walls vary depending on the stones available within reach, with different construction styles. At the same time, there is no clarification on how to address cases where walls made of the same material but with different quality of execution are located in close proximity. Nor is it specified what exactly is meant by construction styles. As a result, it is often impossible to determine the type of structure being referenced, whether it is a terrace retaining wall made of rough stone or a facing of polygonal blocks. Meanwhile, this is a key point. And it's not just about the fact that polygonal masonry can provide a level of strength that rough stone masonry cannot. Nor is it solely about their different appearances. There are deeper and more significant differences beyond just aesthetics or strength. Among these differences, the construction features, which are directly related to the method of stone preparation, should be highlighted first. It is impossible to achieve the same level of tight-fitting joints in rough, unshaped stone masonry as in polygonal masonry. To hold the terrace body, which consists of layers of gravel, clay, and soil, such walls were built using one or more rows of stone. Polygonal facing, however, is always single row. It consists not of rough stones, but of processed blocks that fit together perfectly. Additionally, the rear parts of the blocks are embedded into the embankment, forming a unified structure with it. These differences are also well reflected in the appearance of the masonry. The best illustration can be seen in the terraces of Ollantaytambo. On the left is a typical polygonal facing, while on the right are masterfully executed terraces made of rough stone. When constructing simple masonry, there is no reason to give stones complex shapes, and neither the Incas nor modern restorers engaged in this practice. Such masonry is created by selecting material of suitable size and shape, or by making rough, superficial adjustments to the shape of the raw stones. Polygonal facings, however, are more complex because the blocks required a tight fit, which could only be achieved through careful processing of their side surfaces. Even here, there is no uniformity. There are different variations, the main distinction being the surface areas intended for jointing. The first type features joint surfaces that are equal to or nearly equal to the depth of the masonry. In this case, the side surfaces of the block have large areas and require considerable effort and resources for preparation. The rear part remains small and unprocessed, as it is embedded into the embankment. In another variant, the joint surfaces are significantly smaller. These are primarily small sections of the side surfaces adjacent to the front faces. In this case, most of the block remains as rough stone and is completely embedded into the embankment. Special elements are also often observed, designed to further secure the block's position in the masonry, such as wedge-shaped projections at the lower part of the blocks. It is sometimes the case that one of these variants predominates. However, more often than not, both are used simultaneously. The determining factors were likely the sizes of the stone blanks and the specific requirements of the structure. Striking examples of such masonry can be found on the terraces below the Temple of the 10 Niches in Ollantaytambo or in Tipon. Although in Tipon, the joints between blocks are sometimes not meticulously worked, the material used is still properly shaped blocks rather than rough stone. These blocks have a prepared form, and their profile configurations are well fitted. Researchers note, the terrace walls in Tipon exhibit high-quality construction, as evidenced by the careful finishing and fitting. There are also intermediate variants that do not fit neatly into either polygonal masonry or rough stone masonry. Since we are focusing on terraces, we will limit ourselves to merely mentioning them. These are cases where the joint surfaces underwent only minimal preparation, as seen, for example, in Machu Picchu. In some cases, they were not modified at all. Machu Picchu itself provides a good example of the combination of megaliths and smaller stones without any shape correction. Such masonry often transitions into high-quality joint work, indicating that they were likely built by the same craftsman. Clearly, the characteristics of polygonal masonry elements and rough stone masonry imply different methods of their production. This suggests the existence of distinct technological bases, from the initial extraction of the stone blank to the final placement of the stone or block in the structure. Given such significant differences already at the material preparation stage, we have every reason to expect that further distinctions may emerge at a higher level. And indeed they do. There are a number of differences that pertain to the structures themselves. For example, terraces with rough stone retaining walls are more commonly found on slopes that are not very steep. Exceptions exist, but they are rare. The top layer in such terraces consists of soil, which can reach half a meter or even more in thickness. Their usable area is always sufficient for growing cultivated plants. They are positioned on slopes in a way that ensures the necessary levels of sunlight and temperature conditions. Overall, these terraces give the impression of structures well prepared for agricultural use. The retaining walls of such terraces may even include decorative elements, geometric patterns, or animal figures laid out in stone. Terraces with polygonal masonry facings differ in every one of these aspects. First, they are often built on rather steep rock slopes, sometimes with inclinations exceeding 60 degrees. Constructing terraces in such conditions is a challenging task in itself. The structure must at the very least not slide down the slope under its own weight. This requires a properly prepared foundation. Additionally, a well-planned logistic system is necessary for both the masonry construction and the filling of the terrace body with material. Logistics are also required for obtaining the necessary stone fractions and transporting them to the construction site. Second, among terraces with polygonal block facings, there are many where agricultural use would have been clearly impractical. In some cases, it would have been outright impossible, as the horizontal surface area is obviously insufficient for cultivation. Moreover, access to these terraces is often difficult. Building such a structure on an inaccessible slope just for a planting bed the size of a meter by a meter would be as labor-intensive as it is pointless. Sunlight exposure poses a similar issue. On some terraces with polygonal masonry facings, the lighting conditions would have been clearly inadequate for growing cultivated plants. And in cases where terraces are located at the peaks of mountains, maintaining a stable temperature regime would have inevitably become a challenge. There is yet another aspect to this issue. Here, for example, is a satellite image where agricultural terraces in the Pisac area are clearly distinguishable. And here is another image showing cultivated land plots in the Ollantaytambo region. There are also terraces made of rough stone in this area. If one knows where to look, they can still be identified in the image. However, it is already evident how minuscule their area is compared to the surrounding cultivated land. Terraces with polygonal facings, on the other hand, are almost impossible to discern in this image. Even when their locations are known, they remain difficult to spot. The expected return from such structures is vastly disproportionate to the effort required to build them. It is akin to using a multi-ton press just to drive in a single nail. Questions also arise regarding the filling of these structures. If they were made excessively narrow, with no apparent intention of being used for agricultural purposes, then a fertile topsoil layer would not have been necessary. Another important point must be considered. Because structures with polygonal facings are situated on steep slopes, they inevitably integrate into the natural contours of the terrain. As a result, their shapes generally follow the topography of the slopes, either exactly or with some variations.
For example, one theory suggests that the terraces below the so-called Temple of the Ten Niches in Ollantaytambo originally had a level surface along their entire length, and that the depressions in the central part of the two lower terraces were caused by some catastrophic collapse.
However, upon closer inspection of the masonry details, it becomes apparent that the terraces to the left and right of these depressions, except for the lower right one, are faced uniformly around their entire perimeter, both at the front and on the sides. This facing appears to be a single, cohesive structure, showing no signs of destruction or later modifications. The same applies to the rear sections of these depressions. They are formed by the polygonal masonry of the terrace section above. It is difficult to determine how deep this masonry extends, but the assumption that it reaches down to the bedrock is not without merit. On the left, outcroppings of bedrock can be seen, remaining exposed. At first glance, these might appear to be piles of material or debris, but in reality, they are the visible crest of the underlying bedrock. A similar outcrop is present on the right. The masonry is seamlessly integrated into its configuration. It is evident that beneath the flat sections of terraces, rock ridges are concealed. Where there is a depression, a natural hollow exists between these ridges. Moreover, the depth of the depression correlates well with the depth of the hollow. Beyond the previously mentioned differences, it should also be noted that terrace-type structures with polygonal facings are relatively few in number. They are significantly rarer than terraces with retaining walls made of rough stone or those with walls of partially shaped stone. Furthermore, they are always associated with polygonal complexes, whereas terraces made of rough stone can exist independently. Thus, under the general label of terraces, we are actually dealing with two distinct types of structures. They have different engineering solutions, different construction methods, and different purposes. Despite some superficial similarities, they fundamentally differ in every aspect. So what do they have in common? Is their placement on mountain slopes, their stepped form, and that is essentially all. Even the fact that terraces made of rough stone can be of grand scale and complex configuration does not make them related to polygonal masonry structures. In the vast majority of cases, they are the result of generations of relentless labor by indigenous people. They are the product of numerous modifications and reconstructions. They are the result of continuous expansion and improvements over a long period of time. Polygonal masonry, on the other hand, is the outcome of a much more compact and unified event, shaped by certain technological characteristics of its construction. But if terraces with polygonal facings were not intended for agricultural use, then what purpose did they serve? Some researchers suggest they may have had a fortification function. However, upon closer examination, this theory also proves to be unconvincing. These structures are often adjacent to such inaccessible sections of rock that an assault there would make no sense. There would be no need to reinforce such cliffs with polygonal masonry for defensive purposes. Moreover, their design fundamentally contradicts the principles of creating barriers that are difficult for enemies to overcome. Their height is insufficient to create a serious obstacle, yet it is enough to provide attackers with cover from arrows, stones, and spears hurled from above. Additionally, the horizontal platforms would not hinder an advancing force, but rather facilitate their movement upwards. Climbing an unprepared slope is far more difficult. So if structures with polygonal facings were neither intended for food production nor for defense, then what were they for? First of all, the very premise of the question is incorrect. These structures should not be classified as terraces. They are not terraces. Not even when they provide enough usable space for plant cultivation, and not even when vegetation is growing on them. They have no connection to agriculture, fortifications, or even, for example, slope stabilization against landslides. A definition is needed that accurately reflects their essence, and it could be as follows. They are complexes of co-located platforms, with a rocky core as their foundation. This definition corresponds to what we observe in structures with a rock core within polygonal complexes. What we see here is one of their variations, a greatly enlarged and somewhat more complex version. This construction principle recurs consistently. A pronounced example of its application can be seen not only in Ollantaytambo, in the platforms below the Temple of the Ten Niches, and around the summit of the ridge. Machu Picchu offers an equally striking example. Everything here consists of a summit onto which platforms and other structures have been placed. Neither their placement on the rock slopes, nor their shape, nor their spatial arrangement gives any reason to assume an agricultural or defensive purpose. The only remaining possibility is that the rock foundation and the constructed platforms are interconnected in some way, that they complement each other to fulfill a unified function.